Okay, hi. Okay, so today too, I want us to solve some MCQs on magnetic properties of materials. So here we need a basic concept in magnetism. Okay, so we are beginning our question. Question one: the susceptibility of diamagnetic material is A positive, B negative, C 0, D none. So the answer is negative. Okay. So always the diamagnetic material is having a negative value and it is small. And here are the clues. You know that a paramagnetic material is positive and small. And also a ferromagnetic material is also positive and large. Okay, so para is positive and small, ferro is positive and large. Therefore, the diamagnetic material will definitely be negative and small. So this is the answer. Okay. Question two. Which material has a UR greater, double greater than 1? So a diamagnetic material is having, the clue is that a diamagnetic material is having the UR to be less than 1, and the paramagnetic material too is having a UR greater than 1. So the ferromagnetic material is only the material having the UR to be greater or um, greater greater than 1. Okay, so this is far greater than 1, unlike the paramagnetic material. Okay, so the answer is C. Question 3. Find the correct relationship between XM and the UR. So, Abi, when we were learning the magnetic materials or engineering materials, you learn something about XM, that's the magnetic susceptibility, and UR. And we came across this expression. XM is given by UR minus 1. So this is the correct relationship between XM and UR. Okay. So question 4. Above which temperature magnetic material lose diamagnetic property? So the answer is Curie temperature. So we have Curie temperature, Seebeck temperature, the Peltier temperature, and none. Okay, we have also another temperature we call the new temperature. So we will come across that. But the Curie temperature is above which the temperature a magnetic material will lose their magnetic property. So it's only the Curie temperature. So above that temperature, the magnetic material will lose its magnetic property. Okay. Question 5. Aluminium is an example of, so the answer is paramagnetic material. Okay. So copper is diamagnetic material. Aluminium is paramagnetic material. Iron is ferromagnetic material. So there are some materials we need to know. Okay. So question 6. Copper is an example of, so as I even said earlier on, copper is an example of a diamagnetic material. Okay. Okay. Question 7. At the new temperature, which material is changed into the paramagnetic material? So the answer is antiferromagnetic materials. Remember, for the types of ferromaterials, um, we have antiferromagnetic materials, we have ferrimagnetic materials. Okay, so they are at this new temperature, the material will change into a paramagnetic material. It's only the magnetic materials. That's where the electrons are being unpaired. Okay, um, they are not arranged, or they are arranged unequal. So this is the clue. So I just drew this one here. You see, the electrons are not arranged equally. So immediately this temperature is reached, the material will be able to turn into paramagnetic materials. So the behavior of this material is antiferromagnetic. Okay. So question 8. A ferrite is an example of. So the answer is a ferrimagnetic material. A ferrimagnetic material. Okay. So the name even suggests. Okay. So I just drew this one for us to know the reason why it is a ferrimagnetic material due to the arrangement of the dipole moment. See how the dipole moment is arranged. So normally ferrites are arranged in as the same thing as how a ferromagnetic material is arranged. That's the dipole moment. Okay. So question 9, which of the ferromagnetic material does not depend on temperature? So we know that a paramagnetic material depends on temperature. A ferromagnetic also depends on temperature, but you know that the when we apply the Curie law, only the diamagnetic material is not applicable. It doesn't follow the Curie's law. Okay, so the diamagnetic materials are only, or they are the only type of magnetic material that do not follow the Curie's law, and hence it does not depend on temperature, as the Curie's law um, suggests. Okay, so the next question is, which of the following material is strongly magnetized in the external magnetic field? So the answer is ferromagnetic materials. For diamagnetic materials, the clue I gave is that the repair, see the die or the magnetic moment repair by external magnetic field. And for paramagnetic materials to immediately we apply a field, they are weakly magnetized. So they are weakly magnetized by the external field. So only ferromagnetic materials are strongly magnetized. Okay. Question 11. In which material the magnetic anisotropy is follow? Okay. So the only one that will allow or cause the magnetic moment to become a para is the ferromagnetic. Okay, so the ferromagnetic materials. Okay, the next question. Find the susceptibility when the Curie constant is 0.2 and the difference in critical temperature and paramagnetic Curie temperature is 0.01. Okay, so the relationship between the magnetic susceptibility Xm and the Curie temperature is Xm is equal to C over T minus theta. Okay, so in some books they write Tc, but we have been given the difference in the critical temperature. So we have been given this difference. And C is a materials constant. So that's the Curie constant, which is 0.2. So just make a substitution. Now the difference is 0.01 that was given. And the C2, that's the Curie constant, is 0.2. So your Xm is 20. Okay, so the answer is B. The material having very small susceptibility at all temperatures are, so the answer is antiferromagnetic materials. The clue is that for antiferromagnetic materials, the Xm, that is the magnetic susceptibility, is inversely proportional to the temperature. Okay, so for all temperature, because we are dividing by a larger value, okay, because for very, it means the Xm is going to be small for all higher temperatures. Okay, so for all temperatures, the Xm is inversely proportional to the temperature, and that's the relationship for antiferromagnetic materials, and hence the susceptibility will always become very small. Okay, question 14. The susceptibility Sm of a paramagnetic material is inversely proportional to the temperature. Okay, so this is the relationship for the susceptibility and um, temperature. But remember that the susceptibility the susceptibility will become small for antiferromagnetic materials. Okay, unlike the diamagnetic and the ferro. Okay, so question 15. The ratio of the intensity of magnetization to the magnetic field H is called the magnetic susceptibility. Know that magnetic susceptibility or magnetization, capital M, magnetization is equal to magnetization is equal to Xm times H. So making the Xm the subject, you are going to get Xm to be M over H. Okay, so the Xm is the magnetic susceptibility, the M is the magnetization, and the H is the magnetic field. Okay, so the ratio will give us the magnetic susceptibility Xm. Okay, the material that is suspended freely in the magnetic field and lines perpendicular to the field is, so the answer is diamagnetic materials. So for diamagnetic materials, they always have their magnetic field and lines perpendicular to the field, and they are freely also suspended. Okay, so question 8, sorry, let's see, question 17. At certain temperature called the Curie temperature, the answer is B. You see, the ferromagnetic material becomes paramagnetic. So always keep in mind that at a certain temperature called the Curie temperature, the ferromagnetic will, the moment will align, and they will become a paramagnetic materials. Okay. So what we should also bear in mind that at a certain temperature called the knee temperature, an antiferromagnetic material becomes a paramagnetic material. Okay, so just get this clue too. And question 18, the material which exhibits hysteresis is, so the answer is ferromagnetic materials. Okay, so they only exhibit an hysteresis. So iron is an example of, the answer is a ferromagnetic material. Okay. Thank you very much for watching.